Sections 2.5, 3.6, and A10, Inequalities of the linear, quadratic, polynomial, and rational variety. So first, let's just remind ourselves of how to deal with linear inequalities. And so if I have this inequality, -1 is less than or equal to x is less than or equal to 5, the interval notation for that is bracket, -1 up to 5, close bracket. And then the graph will match our interval notation. That is, it will go from -1 up to 5, and it's going to be inclusive. So that is bracket on -1 all the way up to 5, and there's our graph. Then if I'm given interval notation from 4 to 12 with a parentheses on 4 and a bracket on 12, notice that that's going to be from 4, not including, so strictly less than x, less than or equal to 12. And then for our graph, we go from 4 to 12. That is not including 4, so a parentheses on 4, a bracket on 12, and everything in between. X is greater than 2, that is not including 2, up to infinity. And so for our graph, give myself a 0 for reference, 2, that goes not including 2, and everything to the right. If it's from -infinity to -3, that is x is less than or equal to -3, because of the bracket, the equality is there. Then for reference 0, 3, then our graph goes from -3 and everything to the left. -2 to 6, not including either endpoint, and then our graph, -2, 6, it's going to be parentheses on both of those endpoints and everything in between. For each of these, we want to express the solution in set builder notation and interval notation, and then graph the solution set on a number line. Which means the first thing that we need to do is solve these. So solve for x, -4 minus 4, -7x is less than or equal to 41. Then divide by -7. But recall that when we divide by a negative number on both sides, this is then going to change the direction of the inequality. X is then greater than or equal to -41/7. That won't reduce, and so then if we want to write it in interval notation and set builder notation, well, here's the set builder notation. Just put set braces x such that x is greater than or equal to -41/7. There's our set builder notation. Our interval notation is going to be a bracket on -41/7 and then goes to infinity. Remember that infinities only ever get parentheses because it's an idea, not a number. And then for the graph, it should match up with our interval notation. So from -41/7, and for reference, let's put a 0 here. Then this is a bracket on -41/7, and then everything to the right. For 4x minus 3 is greater than 6 plus x, step 1, solve for x. So we need to get all the x's on one side. So how about we minus x, and then I'm going to add 3. This thing gives me 3x is greater than 9. Divide by 3. Division does not change the direction of the inequality, but division by negative does, so this is going to stay the same. That is x is greater than 3. Then if I want to quickly change that to set builder notation, that is the set of x's such that x is greater than 3. Then to make that interval notation, that is parentheses on 3 and everything to the right. So 3 to infinity with a parentheses on both ends. And then for our graph, let's put 0 here for reference and a 3. And then this goes from 3 with a parentheses thing to the right. Notice that we have some fractions in here, and so if we wanted to find the LCD and multiply everything by the LCD, we could do that. Notice that the LCD is 4, so I can multiply everything by 4. That's going to give me 2x is less than or equal to 4 minus x. Then isolate x, so add x, 3x is less than or equal to 4. Divide by 3, x is less than or equal to 4/3. To quickly make it set builder notation, that is the set of x's such that x is less than or equal to 4/3. Then for interval notation, that is from -infinity up to 4/3 with a bracket for the equality. Then our graph will line up with this. That's going to be, give a 0 for reference, up to 4/3. That's going to be a bracket on 4/3 and everything to the left. For compound inequalities, remember that if you have an inequality of the form a is less than x is less than b, you could add equality as you see fit, but remember that's an and statement. You could separate it, and if you wanted to separate it, that would be a is less than x and x is less than b, and then you could solve those two independently, or you can leave it as is and then you can work with the three pieces to solve all at once. So for each of these, we're going to do the same thing. If I have negative 5 is less than 3x minus 2 is less than or equal to 7, step 1, isolate the x in the middle. So add 2 to all sides. That's then negative 3 is less than 3x is less than or equal to 9. Then divide by 3. Divide by 3. Then I get that this is negative 1 less than x less than or equal to 3. Remember that I divided by a positive number, and so no direction of the inequalities change. Then we could make this set builder notation very quickly. That is the set of x's such that negative 1 is less than x is less than or equal to 3. Then for interval notation, that is parentheses on negative 1 up to 3 with a bracket. Then for the graph, it'll match up with our interval notation from negative 1 to 3. That's going to be a parentheses on negative 1, a bracket on 3, and everything in between. Then if I have negative 3 is less than 2x minus 1 divided by 4 is less than 0. First off, if you want, because this is a rational expression, I see that I could clear the fraction, so I could multiply everything by the LCD, which is 4. Which means that then I'm going to get negative 12 is less than 2x minus 1 is less than 0. Add 1. Add 1, add 1. That is negative 11 is less than 2x is less than 1. Divide everything by 2. That's then going to give me negative 11 halves is less than x is less than a half. Then to make it set builder notation, that is the set of x's such that negative 11 halves is less than x is less than 1 half. Then to make this interval notation, that is from negative 11 halves up to 1 half, not including either endpoint. Then for our graph, which will match the interval notation, that's going to go from negative 11 halves up to 1 half, parentheses on both endpoints, and everything in between. Minus 1, minus 1, minus 1. 0 is less than or equal to negative 1 half. X less than 3. Then if you want, you can clear the fractions by multiplying everything by negative 2, or you could divide by negative 1 half. Note that those two things are the same. But if I multiply everything by negative 2, clear the fraction, we're going to get 0. We multiplied by a negative, so the direction of the inequality changes. Negative 2 times negative 1 half becomes positive 1 times x, which is greater than negative 6 now. And for the sake of preferences here, I'm going to rearrange this, and this is the same thing as negative 6 less than x less than or equal to 0. Notice that the inequalities are all pointing at the same thing they were pointing at before, even though I flipped it. Then to make this set builder notation, this is the set of x's such that negative 6 is less than x is less than or equal to 0, which in interval notation is parentheses on negative 6 up to 0 including, and then that matches up with our graph, which is going to go from negative 6 up to 0. Notice that we have a parentheses on negative 6 and a bracket on 0 and everything in between. Now we want to know, where is this function greater than 0? And so greater than 0 is this idea that it's above the x-axis. So where's it above the x-axis? Well, notice that this piece right here, this is above the x-axis. Notice that this piece right here, this is above the x-axis. And because it says strictly above the x-axis, the point that lands on the x-axis, we're going to kick that out, or we're going to leave it out. We're going to exclude it. And so we're going to always answer where the functions are above or below the x-axis based on the x values. And so the x values for which this function is above 0 or bigger than the x-axis is going to be from negative infinity up to negative 4, but not including, because once again, negative 4, 0 is on the x-axis, and we don't want to include that value. Then we need to take a union with the other piece, which goes from 3 up to infinity. Once again, notice that we do not include that endpoint 3, but that's strictly because of the lack of equality here. Then if I want to know where is the function below 0, that is below the x-axis, well, below the x-axis is from here to here. But remember, we're going to answer this in terms of the x values, and that's going to be not including -4, so from -4 up to 3, not including the endpoints because of the strict inequality. Let's try it again. Where is the function f of x greater than 0? That is, where is this function above the x-axis? Well, notice this is above the x-axis, and all of this is above the x-axis. Okay, so where is that? That's from 0 to 1. We are not including because of the strict inequality. We need a union with from 4 up to infinity. Now I want to know, where is the function less than 0? The function being less than 0 really means the y values below the x-axis, or the y values that are less than 0, and so that's going to be all of this, and that's all the stuff that's below the x-axis, or where the function is less than 0. And so once again, we label this in terms of the x values. That's going to be from -infinity up to 0, not including because of the strict inequality, union from 1 up to 4. Once again, we don't include these endpoints because of the strict inequality. Where's the function greater than 0, where the y value is above the x-axis? Notice that's going to be all of this stuff and all of this stuff. That's where this function is above the x-axis. Well, labeled in terms of the x values, that's going to be from 0. Now notice we will not include 0 here because that's a vertical asymptote, and so it doesn't actually exist in the domain of this function, but everything that's really close to 0 will be included. Then this goes until we get to this point, which is going to be 1, not including because of the strict inequality. And then for this next piece, it's going to be union with not including 5 up to positive infinity. Now we want to know, where is this function below the x-axis? Well, notice that all of this stuff is below the x-axis, and this stuff. And so then labeled in terms of the x values, that's going to be from -infinity up to 0, but not including, union, not including 1 up to 5, not including because of course the vertical asymptote. What's going to happen if we're not given the graph initially? Well, that is, you can just use a number line. Now if you wanted to graph them, you could graph them just like we've graphed them in the past, and you could then look at your picture and answer these questions, but you can also use a number line. And so what we're going to do is we're going to find and graph critical numbers. Now critical numbers are just going to be zeros and domain restrictions. So if you find all the zeros and all the domain restrictions of the function, and then you cut up the number line with those values, then you're going to check values between those critical numbers and see if the function is positive, which claims that it's above the x-axis, or if it's negative, which claims that the function would be below the x-axis. Then you have enough information to answer the question, what does the inequality look like? And so here we want to find the solutions to these. If I have x squared minus 3x minus 10, what we need to do is we need to find the critical values. Well, the critical values are the domain restrictions and the zeros. There are no domain restrictions because this is a polynomial, so that means the only thing I need to do is find the zeros. Well, let's solve. X squared minus 3x minus 10 is equal to 0. That factors is x minus 5 times x plus 2. Let's confirm that that's correct. 2 times -5 is -10. 2 minus 5 is -3, and x times x is x squared. That's fine. Then zero product property gives me that x is equal to positive 5 and -2. Those are our critical values. So now I cut up the number line. Then we're just going to choose values between these critical values, to the left, to the right, and in between. So what's a value to the left of -2? How about -3? So let's just calculate f of -3, which is going to be -3 quantity squared minus 3 times -3 minus 10. That's going to give me positive 9 plus 9 minus 10. That's a positive number, so it's above the x-axis to the left of -2. Now we need to check a value between -2 and 5, so let's just plug in 0. F of 0 is going to be 0 squared minus 3 times 0 minus 10, so that's going to be negative 10. That's a negative value, so there it's going to be below the x-axis. Then we need a value to the right of 5, so let's try f of 6. F of 6 is going to give me 6 squared minus 3 times 6 minus 10. But if you check that in your calculator, that's going to give you a positive value, and so that's above the x-axis. Well then, with all this being stated, notice that the critical numbers here is really what allows us to know, do we cross the x-axis somewhere? And so the places where it's positive is where it's above, and the negative is where it's below. Because of the strict inequality, my solution set here is going to be from negative 2 to 5, not including the endpoints. And so that is where this inequality is less than 0. Next one follows the same pattern. First, let's find the zeros. So I'm going to factor this. That is x times x plus 8. Finding the zeros here, that is x is equal to 0 and x is equal to negative 8. And so then we take our number line and we cut it up. So there's a critical point on negative 8 and on 0. And so now, since I'm cut up here and here, I need to find a value to the left of negative 8, calculate that. That's going to be f of negative 9. Negative 9 plus 8 is negative 1 times negative 8. That's going to be positive, and so this is above the x-axis. Then between negative 8 and 0, how about we calculate f of negative 1? That's going to be negative 1 times negative 1 plus 8. Negative 1 plus 8 is positive 7. Positive 7 times negative 1 is negative, so between negative 8 and 0, it's going to be negative or below the x-axis. And then to the right of 0, how about we calculate f of 1? F of 1 is then going to be 1 times 1 plus 8. 1 plus 8 is 9. 9 times 1 is 9. That's going to be positive or above the x-axis, which means that our solution set is going to be from negative infinity up to negative 8, not including, because of the strict inequality, union from 0 up to infinity. And so this is the interval for which this function is greater than 0, or that is above the x-axis. Notice that in the previous ones we had an inequality related to the 0, and so we always want to start with that. So how about we subtract 4, then I get x squared minus 4 is greater than or equal to 0. Then we know that we're looking for the positive solution sets after we find the critical values for x squared minus 4. But x squared minus 4 factors is x plus 2, x minus 2. And so if that's equal to 0, then my critical values are x is equal to negative 2 and positive 2. So then on a number line, this is from negative 2 to positive 2. And since those are our critical values, I just need to find values to the left, in the middle, and to the right. And so how about we calculate f of negative 3. F of negative 3 is just going to be negative 3 squared minus 4, but that's going to be positive 9 minus 4, or a positive value. Then, if I calculate a value between negative 2 and 2, how about f of 0? F of 0 is going to be 0 squared minus 4, or a negative number. Then I can calculate something to the right of 2. How about f of 3? But f of 3 is going to be 3 squared minus 4, which is again positive. Notice now that we're looking for the values where the function is bigger than or equal to 0. So where is this thing bigger than or equal to 0? Well, we already figured out that x is equal to 0 at negative 2 and 2. So that means that these endpoints will be included. They will have a bracket on them. But we need the parts that are above 0, or the positive values. And so our solution is actually going to be from negative infinity up to negative 2, and this time we will include that 2, union including the 2 up to positive infinity with a parentheses. And so this is where our function x squared minus 4 is greater than or equal to 0. Next one, I have 6x squared minus 1 is less than or equal to 5x. First thing, I should get everything on one side of the inequality with relation to a 0. So I'm going to do two things in the first step. I'm going to distribute the 6. That's going to be 6x squared minus 6, and then I'm going to move the 5x over, so I'm going to subtract 5x. That's less than or equal to 0. So then I get 6x squared minus 5x minus 6, and I need to solve this for 0 so I can find those critical values. A little bit of side work to factor this. So using the AC method, negative 6 times 6, that's going to give me negative 36. Now I'm looking for two numbers that multiply to give me negative 36, but sum to be negative 5. Those are negative 9 and positive 4. Notice that negative 9 plus 4 is going to equal negative 5. And so then I can force the factor by grouping. 6x squared minus 9x plus 4x minus 6 is equal to 0. Forced the factor by grouping. This is then going to be 3x times 2x minus 3 plus GCF of 2 times 2x minus 3. So this is 2x minus 3 times 3x plus 2. And so then using the zero product property, I get 2x minus 3 is equal to 0, and 3x plus 2 is equal to 0. That's then going to be that x is equal to 3/2 and negative 2/3. And so now I have my critical values, negative 2/3, 3/2. So then I need to pick values to the left, to the right, and the middle. To the left of negative 2/3, how about negative 1? So f of negative 1, that's going to be 6 times negative 1 squared minus 5 times negative 1 minus 6. Check that calculation, you'll see that you'll get a positive value. Then I need to choose something between negative 2/3 and 3/2. That is, how about 0? But f of 0 here is going to be equal to negative 6, so that's negative between those two values. Then I need to pick a value to the right of 3/2. How about 2? F of 2 is going to be 6 times 2 squared minus 5 times 2 minus 6. But if you check that value in your calculator, you should get plus. Then notice that our solution set is going to be the stuff that is less than or equal to 0, or the negative values, and so our solutions are including negative 2/3 up to 3/2, and there's our solution set where our function is less than or equal to 0. Again, starting with the critical values, this is already nicely factored and in relation to 0. So my critical values are positive 3, positive 5, positive 6. Then let's cut up the number line. 3, 5, 6. Because of the equality, we will include whichever endpoints we get. And then I need to just test values. So how about f of 0? That's going to be negative 3, negative 5, negative 6. Negative times negative is a negative. And so to the left of 3, it's going to be below the x-axis. Then between 3 and 5, let's pick a value. How about 4? F of 4. 4 minus 3 is positive 1. 4 minus 5 is negative 1. 4 minus 6 is negative 2. Negative times negative is positive. Between 3 and 5 will be positive. Then how about we pick a value between 5 and 6? How about f of 5.5? 5.5 minus 3 is going to be positive 2.5. 5.5 minus 5 is going to be positive 0.5. 5.5 minus 6 is going to be negative 0.5. And then I find that negative times positive is negative. Then I need to pick a value to the right of 6. How about we calculate f of 7? 7 minus 3 is positive 4. 7 minus 5 is positive 2. 7 minus 6 is positive 1. And so that's going to be a positive number or above the x-axis. Then we're looking for the intervals where the function is bigger than or equal to 0, or where they're positive. And so then our solution set will be all the positive intervals where we do include the endpoints because of the equality. So that's going to be including 3 up to 5, including 5, union, including 6, up to infinity. Then for our next one, we have 2x cubed is greater than negative 2x squared, but I need to put everything on the same side so we get a relationship with 0. And so then I get that I've got 2x cubed plus 2x squared is strictly greater than 0. Then we need to solve this for 0, so how about 2x squared times x plus 1 is equal to 0? That means that our critical values x is equal to 0 and negative 1. So then I cut up my number line on negative 1 and 0. Now I need to pick values to the left of negative 1, between negative 1 and 0, and to the right of 0 to see where this thing is positive or negative. Notice that it's a strict inequality, which means the endpoints will not be included. So how about we calculate f of negative 2? Negative 2 squared is 4. 4 times 2 is 8. Negative 2 plus 1 is negative 1. Negative 1 times 8 is negative, so to the left of negative 1 is negative. Now pick a value between negative 1 and 0. How about negative 0.5? Negative 0.5 squared is positive 0.25. 0.25 of 2 is a half, times negative 0.5 plus 1, which is also going to be a half. And then positive times positive is positive. Then let's pick a value to the right of 0. How about 1? So f of 1, that's going to be 2 times 1 squared. 1 squared is 1, which gives us 2. Then 2 plus 1 is 3. 2 times 3 is positive, so it's positive here. Now we're looking for the places where this thing is strictly greater than 0, so we're looking for the positive. But because of the strict equality, this 0 gets ignored, and so we're going to have a union. That's going to be not including negative 1 up to 0, not including 0, union, not including 0, up to infinity. Here we have x cubed minus 5x squared minus 24x. We're going to have to factor it and find our zeros. That is x times x squared minus 5x minus 24. Find those critical values. Two numbers that multiply to give me negative 24 but sum to be negative 5. That's going to be negative 8 and positive 3. Let's confirm that. 3 times negative 8 is negative 24. 3 minus 8 is going to be negative 5. And x times x is x squared. That means that zero product property gives me that x has 0, 8, and negative 3 as a solution. So let's cut up our number line. So our number line is cut on negative 3, 0, and 8. Those are our critical values. Now we need to check values to the left, in between each interval, and to the far right. So how about we calculate f of negative 4? That's going to be negative 4 times negative 12 times negative 1. Negative times negative times negative will also be negative. Then let's pick a value between negative 3 and 0. How about f of negative 1? Well, that's going to be negative 1 times negative 1 minus 8 is negative 9. Negative 1 plus 3 is positive 2. And so negative times positive is going to be positive. So in that interval, it's above the x-axis. Then let's pick a value between 0 and 8. How about f of positive 1? That's going to be 1. 1 minus 8 is negative 7. 1 plus 3 is positive 4. Positive times positive, that's going to be a negative. That's below between 0 and 8. Then I need to pick a value to the right of 8. How about f of 9? That's going to be 9. 9 minus 8 is positive 1, and then 9 plus 3 is 12. Positive times positive is positive, and so that's above the x-axis. Then we're looking specifically for the intervals that are strictly below the x-axis, and so that's going to be from negative infinity up to negative 3, not including, union, not including 0, up to 8, not including. Notice now that we have a rational expression inequality, and recall that these critical values that we're looking for are two things, domain restrictions and zeros. So notice that the domain restriction x cannot equal 0 is true. And also notice that if we set the numerator equal to 0, we get x minus 6 is equal to 0 and x plus 8 is equal to 0, which means that my zeros are actually going to be 6 and negative 8. Now, when we cut up the number line, I want us to be careful, because domain restrictions don't actually exist in the graph, and so regardless of equality or not, domain restrictions will never, ever, ever be included in our intervals, whereas zeros, because of this equality here, could be in our solution set. And so let's cut up our number line. That is negative 8, 0, and 6. Now we have our critical values, but I want to make note. Negative 8 could be a solution because of the equality. 6 could be a solution because of the equality. But 0 is a domain restriction, so 0 can never be included. It will only ever get a parentheses if it's an endpoint of the solution set. So then I need to pick values, plug them in, and see if we're above or below. So how about I plug in f of negative 9. That's to the left of negative 8. And so that's going to be negative 9 minus 6 is negative 15. Negative 9 plus 8 is negative 1. Divided by negative 9. Notice negative times negative is positive. Divided by negative, negative. So that to the left of negative 8 is below the x-axis. Then between negative 8 and 0, how about we try f of negative 1. Negative 1 minus 6 is going to be negative 7. Negative 1 plus 8 is positive 7. Divided by negative 1. Negative times positive is negative. Divided by negative is positive. So between negative 8 and 0, it's above the x-axis. Then we need to pick a value between 0 and 6. How about f of positive 1? 1 minus 6 is going to be negative 5. 1 plus 8 is going to be positive 9. Divided by positive 1. Negative times positive is negative. Divided by positive, that's negative. So between 0 and 6, we're below the x-axis. Then to the right of 6, how about f of positive 7? Then 7 minus 6 is going to be positive 1. 7 plus 8 is 15. Divided by positive 7. Positive times positive divided by positive is positive. And so that's going to be above the x-axis. Well, now remember that we're looking for the values of x where this function is greater than or equal to 0. Greater than or equal to means we're going to include the endpoints. That's going to be this interval and this interval. We need to include the endpoints, but not all the endpoints, because of course, remember, 0 is a domain restriction. And so our solution set is going to be including negative 8 up to 0, not including union, including the endpoint 6 up to positive infinity. Step 1, get this as an inequality with relation to 0, so subtract 1, subtract 1. I get that x plus 7 divided by x minus 11 minus 1 is less than or equal to 0. So this is the inequality that we're going to return to. But I do need to find my critical values. First I need to find my domain restrictions, and notice that that's x minus 11 cannot equal 0. And so I get that x cannot equal 11. So that's one of my critical values, but of course it will not be included in our solution set. It will never get a bracket. Then I'd like to solve this. So if I've got x plus 7 divided by x minus 11 minus 1, if I set that all equal to 0, as it is, I can just multiply everything by the LCD, x minus 11, x minus 11, x minus 11, and then I get that this is x plus 7 minus x plus 11. Notice that I just took that negative and distributed it, or really the negative 1, and that's going to be equal to 0. Then this is x minus x is 0, and so then I have 7 plus 11 being 18 is equal to 0. This has no solution, and since this has no solution, that means the only critical values that we're going to have is 11. So let's cut up our number line. And for reference, let's give a 0 over here, and then 11. But then my only critical value is 11, but I'm going to go ahead and remind myself this cannot be a solution. It cannot be included. Well, then let's just plug values into our equation. How about we calculate 0? So f of 0 would be 0 plus 7 is 7. 0 minus 11 is minus 11, and then minus 1, but a negative minus number is negative, and so I know that this is below the x-axis to the left of 11. Then to the right of 11, how about f of 12? 12 plus 7 is going to be 19, divided by 12 minus 11 is positive 1, minus 1. 19 minus 1 is positive, and so this is above the x-axis. We're specifically looking for where is the function less than or equal to 0. Notice that it is nowhere equal to 0. Because at this endpoint 11, it's a domain restriction. It doesn't actually exist. And so it's going to be less than 0 from negative infinity up to 11, but not including that endpoint. And once again, it does not include the endpoint because it's a domain restriction and not an x-intercept. Same process here. Get everything on one side. How about minus 5 minus 5? That is 6x minus 5 divided by x plus 2 minus 5 is less than 0. Step 1, we can find the domain restriction. X plus 2 cannot equal 0. That means that x cannot equal negative 2. Then to find the zeros, I can just solve this rational expression. 6x minus 5 divided by x plus 2 minus 5 is equal to 0. Multiply everything by the LCD, where the LCD here is x plus 2. Then I get that this is 6x minus 5 minus 5x minus 10. Notice that I just distributed the negative 5 is equal to 0. 6x minus 5x gives me x. Minus 5 minus 10 is minus 15 is equal to 0. That gives me x is equal to 15. So I have two critical points, x is equal to 15 and x is equal to negative 2. But of course remember that negative 2 could never be included even though this is a strict inequality. But I'm still going to mark it as such so that I don't forget in the future. And so if negative 2 and 15 are my critical values, remember that negative 2 can never be included because it's a domain restriction. But if this had equality, 15 could. And so then, check. So how about f of a value less than negative 2? How about negative 3? F of negative 3. Negative 3 times 6 is negative 18. Negative 18 minus 5 is negative 23 divided by negative 1 minus 5. 23 plus 5 is going to be a positive number. Then let's pick a value between negative 2 and 15. How about 0? F of 0 is going to give me negative 5 divided by positive 2 minus 5. A negative number minus a number is still a negative number. Then I need to pick something to the right of 15. How about f of 16? 16 times 6 minus 5 is 91. 16 plus 2 is 18. Minus 5, that's positive 1/18. So that's above the x-axis. Then remember that we're looking for the solutions where the function is less than 0 or where it's negative. And it's strict inequality, so that's going to be not including negative 2 no matter what happens, and not including 15 this time because of the strict inequality. For what positive numbers will 2 times the cube of a number exceed 6 times its square? So first off, we have 2 times the cube of a number. Exceeds means greater than 6 times that unknown number's square. And so now I have my inequality. 2x cubed is greater than 6x squared, but remember we need to get this as a statement in terms of 0. And so subtract 6x squared from both sides. I then get that 2x cubed minus 6x squared is greater than 0. Notice that we don't have any domain restrictions, so that's not a concern. But we do need to find the zeros, so let's factor 2x squared times x minus 3 is greater than 0, is equal to 0. That is, zero product property gives us that x equals 0 and positive 3. So then, let's cut up our number line, 0 and 3. Then since we found our critical values to be 0 and 3, pick values to the left, between, and to the right. How about f of negative 1? F of negative 1 is going to be negative 1 quantity squared is positive 1 times 2 is 2. And then negative 1 minus 3 is negative 4. And that's going to be a negative number. Then let's try f of 1. 1 squared is 1 times 2 is 2. 1 minus 3 is negative 2. That's again negative. Then let's pick a value to the right of 3. How about f of 4? That is 2 times 16 is 32 times 4 minus 3 is positive 1, but that's positive times positive, and that makes that positive. Now we're looking for the places where 2x cubed minus 6x squared is strictly greater than 0. That's only the positive locations, and so that's going to be from 3 up to infinity. Suppose that the daily cost C of manufacturing X bicycles is given by C of X is equal to 70X plus 4,800. Now the average daily cost is given by C bar, which is equal to 70X plus 4,800 divided by X. We want to know how many bicycles must be produced each day in order for the average cost to be no more than $130. So notice that no more is less than or equal to. And so that's going to be 70x plus 4,800 divided by x needs to be less than or equal to 130. So now we have our inequality. but we need to get a relation in terms of 0. So how about I subtract 130, subtract 130. I get that 70x plus 4,800 divided by x minus 130 is less than or equal to 0. Then we need to find the zeros in the domain restrictions. But notice that the domain restriction x cannot equal 0. So when we cut up our number line, we're going to need to cut it up with a 0. Also, then we have 70x plus 4,800 divided by x minus 130 equals 0 to find our zeros. Multiply everything by x, which is the LCD. That's going to give me 70x plus 4,800 minus 130x is equal to 0. Then I get that 70 minus 130 is negative 60x plus 4,800 is equal to 0. Minus 4,800. Negative 60x is then equal to negative 4,800. Divide by negative 60. Divide by negative 60. I get that x is equal to 80. So then when I cut up my number line, I have two locations where I cut it up. 0, which was the domain restriction, and 80. Critical values. Notice that 0 is a domain restriction, and this is important because specifically when I deal with my inequality, it's going to be less than or equal to. And so the endpoints might be included if they're not domain restrictions. Then let's just do some calculations. How about f of negative 1? That's going to be negative 70 plus 4,800 divided by negative 1 minus 130. Notice that this is going to be a large number. 4,730 divided by negative 1, which is really negative 4,730 minus 130, which is negative, which means to the left of 0 is a negative value. Then I need to pick a value to the right of 0 but to the left of 80. How about f of 1? F of 1 is going to be 70 plus 4,800 divided by positive 1 minus 130. That's going to be 4,870 minus 130, but that's going to be a positive value, so between 0 and 80 it's positive. Then to the right of 80, how about we calculate f of 81? F of 81 is going to give me 70 times 81 plus 4,800 divided by 81 minus 130. I get that this is a negative number. Now we have to find the places where this function is less than or equal to 0. But I also want to make sure we realize that there's a practical application here. And so if we're talking about how many bicycles must be produced by some factory, then some of these solutions aren't going to make any sense. And so all of the stuff to the left of 0, those are negative bicycle production. And that's not going to happen. They're not going to just tear apart their bicycles. And so then the only places where this function is below or equal to 0, and that makes sense in terms of our problem, is going to be from 80, including, because of the equality, up to infinity. And so this is our solution set for the number of bicycles that must be produced each day in order for the average cost to be no more than $130.